Today, again, some things that you have some introduction to before and that we will just be adding to, making sure that we kind of have a good foundation for, etc., getting into our discussions this year. So, get my screen where I can use it here. Talking relations and functions today, and those words are related to each other but not quite the same. So we've got a relation is any set of ordered pairs, and in that, two words you probably recognize, which would be domain and range up there, right? So reminder of what those mean. Domain is your input to your function. The x values, the range is the output, the answers, or the y value for your set of numbers. Now, we will get to the point where usually a domain and a range are going to be intervals of numbers, of real numbers. But if we're looking at a finite set, like we are up here, this would be called a relation, just a set of ordered pairs. Your domain would just indicate all of the x values that are in that. Now, if we were to happen to have a duplicate x value, you only need it in your domain or range, whichever one it was coming from, one time. Okay, you don't have to list. If 2 was up there twice, you wouldn't list 2 twice. Okay, so our domain, because it's just a set of numbers, we use these curly brackets and list out those x values, our first number in each of those ordered pairs individually. So domain of this set would be 0 and 10 and 20 and 30 and 42. And our range then would be all of our y values. You do not have to list them numerically. You can if you would like to. So 9.1, that does not look like a 6. 6.7, 10.7, 13.2, and 21.7. Any questions on domain or range? X values, Y values, input, output. Okay. And then we move on to what's called a function. Now, a function is a relation, but it's a very specific type of relation in which you only have one range value for each of your domain values. So I have function versus not a function, and we're going to look at this in a couple different ways. Here is where we're just looking at the ordered pairs or the elements of our domain and range. And what I really want to point out is the difference, and I specifically picked this example. This would be like the ordered pair 1, 4 and 2, 4. Now notice there are 2 that use this range value, but for each domain value, 1, 2, and 3, it only draws a line to one y value. That's a key for it being a function. What is not a function is when you have a domain value that corresponds to 2 different range values, like you see in this one. We have the ordered pair 4, 1 or 4, 2, or down here 2, 5 and 2, 7. It's this thing right here, this arrow coming out of a domain, or the fact that we have 2 duplicated as an x value that makes those not functions. Okay, they're still a relation because it's still a set of ordered pairs, right? But it's not a function. Any questions on that? All right. Anyone still need this page? So we're going to look at deciding whether something is a function or not a function in a couple different ways. So we just looked at the specific ordered pairs given on a relation and whether that would represent a function or not a function. What if we have the equation itself? Okay, so what you see up there is examples of equations that represent a function. On the right hand or on the left hand side there, x squared plus y equals 4 and y equals the absolute value of x. And then things that represent not a function, which would be like x squared plus y squared is the key right there, or a y to the 4th equals x plus 2. And guys, it's really going to be this even exponent is kind of what we're going to be looking for. And I want to show you something specifically on this page, and then like 2 pages later, I'm going to try to confuse you. Not confuse you, but hopefully make a clarification. When you're trying to decide if the equation you're looking at is a function, what I want you to do is think about if I were to solve it specifically for y. If I were to do the work to get y completely by itself, would I have more than one answer for y? And what do I mean by that? I'm going to use that top example, and I'm going to solve that for y. So if I solved for y, I would start by subtracting that x squared over. And then I have to be a good algebra student in order to be able to notice what's going to happen here. But as I'm solving, if I use a square root in my solving process, do you remember what I have to include on my answer to that? Plus or minus, right? Well, what that's saying is it really could be either the positive version of that square root or the negative version of that square root. And so what I end up with is 2 different y answers, the positive version or the negative version of what's underneath this radical. Okay, well, guys, that's 2 different answers. That's 2 different y values for the same x that I plug in there. And that's where it falls apart being a function. But notice I was doing the solving for y. So I want you to think about if I have to go through the process to solve for y and I have to like square root, specifically square root or even root to get my answer, that's when you have to put the plus or minus on there. Not for an odd root like a cube root, you don't have to do that. But for an even root, we do. So we'll come back to that conversation in a few minutes here. So now, what if I have a picture of it? I don't have the equation, I don't have the set of points, but I have a picture of the relation. Am I looking at a function or not a function? And we use this thing that's called your vertical line test. Okay, vertical line test. And that is a justification if you have a picture of your relation as to whether or not you say something is a function or not a function. You say, well, it failed or passed the vertical line test. And the vertical line test is what you see up there is you're drawing mine are blue. You're drawing vertical lines through your picture. If you can only hit it at one point ever, it's a function. But if at any time on that picture you could hit more than one point with your vertical line, it's not a function and it fails your vertical line test. Questions? Okay. Take a second and think about what we talked about and decide if you would say that this is a function, defines y as a function of x. Are we looking at a function given this equation? Okay, so take a second and look through those 3 and think about what we talked about. I'm going to skip the first one for a minute because that's actually the one I was kind of referring to that I want to have an in-depth conversation about. So let's go to that second one up there. It says xy equals 3. What do you think? Function or not a function? It is a function. Yeah, that one is actually a function. If I were to solve that for y, I would have y equals 3 over x, and it's a function. Okay, so yes, or function. Maybe I should say function instead of yes. Okay, how about the last one? X equals y squared minus 5. No, not a function, right? We've got that key that we kind of look for here is that y raised to an even. Why am my stuff not showing up there? Not a function. Hold, please. Maybe, there we go. Okay. Sorry, now you can see what I'm writing. Let's go back to the first one. I told you I skipped this one, right? Y equals negative square root of x plus 7. Function or not a function? Function. It is a function. Did anyone hesitate on that one or think it wasn't a function because of what I wrote on the first page that involved a square root? okay? A square root is not the thing that made it not a function, right? It was the fact that we had to put a plus or minus on there. So what's the difference? When I see a square root, doesn't it get a plus or minus? Guys, the difference is, did I insert in the square root to solve? Okay, if I'm not the one that put the square root into the problem, if I'm not the one that introduced the square root to the problem, then it's whatever sign it came to us as. This one is negative. That's what's called its principal value, okay? So it will be negative. Whatever our answer in that square root is, then we turn it into a negative, and that's the answer, and that's the only answer. But if I were solving and I had to utilize the square root to solve, that's when I have to put a plus or minus on there, and that's when we have more than one answer. So if it's already in there, that's a function. So we are actually looking at a function on this first one. Any questions on that? What hopefully was a bit of a clarification. All right, let's keep going. Look at these pictures here. Decide function or not a function. Now, I specifically put the first one on there. I think the second one's pretty obvious. Function or not a function? Not, right? There's my vertical line. Hit more than 1 point, easy. I just want to point out the second one may have given some people some hesitation. What do you guys think? Function or not a function, first of all? Function. Okay. I do want to address, some of those get pretty steep and look like maybe if I drew a vertical line that I would hit more than 1 point. Do you guys kind of see what I'm talking about here? I can't really zoom in very well, but like right in this area, doesn't it look like, would I hit more than 1 point if I had put a vertical line there? You wouldn't. And I will tell you right now that if the whole point is it a function or not a function based off of visual, if it looks like that, it's fine. It is slowly but continuing to move to the right or left, whichever direction you're looking. If they want it to not be a function, they're going to make it pretty obvious like this. Okay, so don't overthink something like that. This would be a function. Any questions for me? Function notation. Function notation is something that we can use interchangeably with a y in our equation as long as what is then around it is a function. Okay, so yes, we decided it's a function. What happens is instead of a y equals, we call it f of x. It allows us a place to indicate what is going to be the input for our function. It's kind of also our transitioning from like an algebra 1 level up to now higher types of math where we use specifically functions. And so with that note, typically on something like this, points on our graph would have looked something like x comma y. Well, now we are talking x comma f of x, where f of x again is our y value, our output, our range value for those. Okay. Questions? Sometimes it'll be easier for us to work with it being a y there, and sometimes it'll be easier for us to work with it being an f of x and know that you can interchange them as long as it's a function. Okay, so evaluating a function. Evaluating a function, again, something we have some introduction to. Remember what is ever inside our parentheses here. F of 2 is how you read that. F of 2. Is telling us what to put in any place that we had an x in our function. So our function is listed up here, f of x equals, and we've got our x squared plus 3x plus 5. And so as I'm teaching this, typically what I do is I say, okay, rewrite that function that's above, but put a parentheses instead of an x. So we have x squared plus 3x plus 5, and then whatever they told us was supposed to be going in for x, we put in the parentheses. So instead, it's actually 2 squared plus 3 times 2 plus 5. 2. And then you just find your answer. So 2 squared, let's see, 4 plus 6 plus 5 is 15. Questions? If it's a number, we will get a number answer, but sometimes we can have variables. So this time, instead of plugging in x, I will plug in x plus 3, the same place that I put the 2's our first time. So again, if I want to kind of go the long route here, I can write it out here, x squared plus 3x plus 5. And this time now, instead of Plugging in 2, I'm going to plug in an x plus 3. Okay. And then we have to be good algebra students. So as I look at that x plus 3 squared, what's that math process I have to do right there? FOIL, right? It is not x squared plus 9. I must write it twice in FOIL. Okay, so FOIL here. FOIL. Or x plus 3 times x plus 3. So we get x squared. Man, this is not like my pen today. X squared plus 6x plus 9. And then what's that math word for this? I don't know how to finish that question without saying the word. What am I doing right there? Distributing. Thank you. Distribute. What? This is getting real bad today. Sorry. And then our little plus 5 on the end there. And then our combined like terms. All right, then combining our like terms, we'd have an x squared. We'd have 6x plus 3x, so 9x. 9 plus 9 plus 5. Questions? I know. I don't know what's going on. It really bothers me because I don't have the world's worst handwriting, but this does not help anything. All right, here we go. Questions. Besides, what number did you just write up there? I can't tell what that is. All right. And I again put this one up here just to have a good talking point. We do have to be careful on our being good good algebra students here. If I again follow our, okay, put in parentheses. Actually, that kind of saves you on this one if I do it this way. Any guesses as to what the common mistake is on this one? When I plug in a negative x, what's the mistake we're going to make? Keeping it negative, right? When I square a negative, it turns out positive. So this first term right here is what we have to be cautious of. And if I don't put the parentheses there, I might make that mistake, right? But negative x times negative x, which is what negative x squared is telling me to do, is a positive x squared. Minus 3x plus 5. Notice our second two answers have x's in them, and that's okay. We clean them up as best we can, and we're done. Questions? All right. We are going to skip this. I think we can all plug that in correctly. Let's talk about visually evaluating a function. Remember for this that when we are talking function notation, that it is f of x, right? So as I think about this being an ordered pair where that is the number we would have in our x, comma, then we would end this with what we see on the graph, and that's your answer. Okay, that's what this equals. So that's what our answer to this would be. Let me give you an example. If it says f of negative 2, we go over to our picture and say, okay, on our graph, where would be the point negative 2, comma, and let our graph fill in the rest of that ordered pair. Well, negative 2 is over here, which also happens to be right there on our x-axis. So that ordered pair would be negative 2, comma, and whatever I fill that ordered pair within is my answer to this, right? That is the value of the function at that point, which in this case happens to be 0. Questions? Okay, so let's go do that with the rest of them. Do f of 0 and f of 1 in our picture. Go to the graph and finish the ordered pair 0, comma, and however you finish that point is your answer to the function value there. 0, comma, my graph's up here. You should have finished it with 1. Your function value at 0 is up at 1. And finally, f of 1, here's x equals 1. My graph is up here. So it looks like that would be up at, let's see if we can make a 3 here. 3. Questions? So then they switch up the question on us and they say for approximate what value of x does f of x equal 2? So this time they're giving us, remember, f of x is your second spot. So they're saying the y value is 2. What x value in this picture gives us a y value of 2? So then I can kind of look at my graph slightly differently. Here's y value of 2, slide along that until we find graph, right? And figure out how would I end that ordered pair, or we'll start that ordered pair. So as we look at that one, what do you think approximately our x value would be? A half, yeah. Or whatever symbol that is I just drew. 1/2. Questions? All right. We are going to not do this as your book intends. I do show you how your book has this, but guys, we don't need this. What they're showing us is that we're showing plugging these numbers into our function and getting the ordered pairs associated with that x value. You don't need that drawn out process. I don't need to, you at this level do not need to write 2 times -2 to show plugging it in. -2 comma f of x, what we get for that, which is -4, right? We can probably just jump to our ordered pairs in this, graph those points, but here's what I want you to do is actually do that, okay? So go to your last column in each of those, give me your ordered pairs, get those graphed, and then we'll talk about how to answer the question, how they are related, and kind of talk about where we are building to with this. All right. Oh, that's kind of hard to see, and there's not much I can do about it. Maybe. Okay. Describe how they are related. Describe how they're related. We would want to kind of look at how are they the same, how are they different. Okay, well, how are they the same? What's a math word we could describe as the same between those two lines? Parallel, which means they have the same slope, right? Same slope, so that could be something we say. Wow, this is getting real bad here. Sorry, guys. I don't know why that's not writing at all. How are they different? Well, G is just moved up 4, isn't it? Slope. Sorry, it's like this pen's running out of batteries or something. Just took the graph and moved it up 4. And what we're going to start looking at is how those are related to the numbers we start seeing in our function. And I know you guys have a little bit of an introduction to transformations on these basic ones. And so we should be able to see this. Not all of them are we going to have to graph by hand. So like this one is going to ask you to go throw these into your graphing calculator. And what do we notice about these two graphs? So if you go quickly graph those two in your graphing calculator. And I just typed both of them in, so into my Y1 and my Y2, and I went back to a Zoom 6. Give me a good window for this. Zoom 6. All right, so what do I notice here? Well, my x squared minus 2 looks like my basic parabola moved down 2, right? And what they're trying to get you to do is leading into, because that's where we're headed with part of what we're doing this semester is transformations, is noticing how then those down 2s and rights and lefts start being related to the numbers that you see in our function, which again, we have a little bit of a preview to before. And then our second one that was moved right 3 and seeing again how that relates to our number that is showing up in our function. Okay. Any questions for me on that? All right, the last thing we are going to look at today is analyzing a graph. And so this one we are given, I'm going to make mine a little bit bigger here. Graph shows the average progress of the HIV disease, the average number of T cells, which is our function, which means function is going to be our y-axis, T cells, and then the function is in time after infection is our x-axis, and they have that listed in years. So think back to what we started with here. I have a picture to look at. That leads us to the right answer here. I have a picture to look at. Explain why f represents a function. We had a process at the beginning of our notes to decide if something was a function or not a function. What was it called? Vertical line test. Does this pass the vertical line test? It sure does. So explain why it passes the vertical line test. Okay, and then it says use the graph to find and interpret f of 8. I know the numberings may be a little obvious on this one, but if it says f of 8, am I going to 8 along our x-axis or along our y-axis? X, right? Remember, that's your x value that's inside the parentheses. Okay, so if I go to that here it is, follow that up until it hits the graph, finish the ordered pair, right? So now follow that over to your y-axis. It would be 8 comma approximately. Follow that over to our y-axis here. Approximately 200, right? 200 what? T cells. You got it. Okay, continuing on with that same picture. Now they flip it on us. For what values of x is f of x 350? If the question is what is the x value, that means they're telling us the y value, right? So for what x would our y value be 350? So go on the y-axis to approximately 350, which is going to be about there-ish, right? Follow that over to your graph. Say, okay, well then how would I start that ordered pair? It looks like approximately 6. 6 what? Years. Okay. And we're going to talk about the math word for this, but general trend, if you kind of just step back and don't get too close to this graph, what's it kind of doing over time? That is the math word. There it is. Decreasing. Decreasing. Questions? All right. Your assignment tonight, after I get past these check for understandings, is out of the book. And once you get that written down, what I would like you to do is go to your My Math Lab that we just got registered for. Finding the e-text on there is not as obvious as you think it should be. Okay, so I want to make sure that we can all find it, access that. Okay, I'm going to